In this lesson, let's study the third key point in the introduction, geological timescale. The development history of the Earth can be divided into several stages. The time period of the Earth's development is called the geological timescale. Geological timescale is divided into absolute geological age and relative geological age. Absolute geological age is determined by measuring the content of radioactive isotopes in rock strata and calculating their exact formation time based on radioactive decay laws. Relative geological age refers to the formation sequence of strata and the relative relationship between old and new. In geological work, generally, relative geological age is mainly applied based on the theory of Laplace's nebula. The Moon was separated from the Earth at the beginning of its formation. So the average composition of the Moon represents the average composition of the Earth in its early days. We can think that the age of the Moon is consistent with that of the Earth. In 2005, according to analysis of lunar rock samples brought back by NASA's Apollo missions, the oldest specimens have been dated to approximately 4.7 billion years. It is estimated that the Earth is at least 4.5 billion years old. The oldest fossil on Earth has been found in Quebec, Canada, is dated to 4.2 billion years ago. Through a comparative study of strata around the world, we divide the geological age into two major stages, Phanerozoic eon and Cryptozoic eon. Eons are subdivided into eras, eras into periods, and periods into epochs. The time units eon, era, period, and epoch correspond to the stratigraphic units eonathem, erathem, system, and series, respectively. For example, the period 2 million years ago to the present is called the Quaternary. The deposited strata are called Quaternary strata. Dinosaurs lived in the Jurassic period. Dinosaur fossils found in Jurassic strata. The basic methods to determine the relative geological age of strata are sedimentary sequence method, biological evolution method, and geological structure relationship method. Let's first look at the sedimentary sequence method. The original sedimentary strata were formed in a nearly horizontal manner, superimposed sequentially from bottom to top. Under normal sequence conditions, the rock formation formed first is below, and rock formations formed later are above the preceding sext. That is, the old down and the new up. Second, biological evolution method. In sedimentary strata of different geological ages, there will contain paleontological fossils with different characteristics. Rock formations containing identical fossils, however far apart, all formed in the same geological age. From single-celled eukaryotes 21 million years ago to birds and mammals about 2 million years ago. The older the formation, the more primitive, simpler, and lower level the organisms it contains. The newer the strata, the more advanced the organisms it contains, the more complex and advanced it is. In addition to sedimentary sequence method and biological evolution method, we can also utilize the structural relationships between sedimentary rocks, as well as between igneous and sedimentary rocks. To determine the relative geological age, the contact relationships of sedimentary rocks are classified as conformable contact, parallel unconformity contact, and angular unconformity contact. Sediment strata of different ages are deposited continuously layer by layer. No interruption in the middle is called conformable contact. Then, how the parallel unconformity contact strata was formed. In the process of continuous deposition of strata, rock formations exposed above sea level by rising crust are weathered and denudated. There were no new sedimentary rock formations during the period, the Ruffive. Subsequently, the crust underwent subsidence again, and the strata continued to deposit, remaining essentially horizontal. However, part of the strata is missing, and this contact relationship is termed an angular unconformity. This is the parallel unconformity surface at the Shaba, Tong'an, Huili County, Sichuan Province. The upper stratum above the unconformity is younger in age, while the lower stratum is older. How was an angular unconformity formed? Let's look at the formation process of angular unconformity strata. First, sedimentation and lithification occur, followed by folding and tectonic uplift. The rocks exposed above sea level then undergo weathering and erosion. And finally, with subsidence, sedimentation, and lithification resume. This picture is typical of angular unconformity strata. The pre-deposition age of the rock strata below the unconformity is relatively old. The post-sedimentary age of rock strata above the unconformity is relatively new. Similarly, the relative geological age of magmatic rocks can be determined based on their contact relationships with surrounding sedimentary strata of known geological age. The formations cut according to the law of cutting are older. Therefore, magma C was formed earlier than magma B and earlier than magma A. The magmatic rock continues to deposit after weathering and denudation. Therefore, the base of sedimentary rocks often contains conglomerates composed of igneous rocks and erosion surfaces, indicating that the igneous rocks formed earlier than the overlying sedimentary rocks. As shown in the figure, the magmatic rock intrudes into the strata formed during the Permian, P. Carboniferous, C. Devonian, D. and Silurian, S. periods. After weathering and denudation, magmatic rocks continue to deposit Cretaceous K. strata. Therefore, magmatic rocks were formed later than Permian and Carboniferous. Devonian and Silurian are earlier than the Cretaceous K. Through the learning in this lesson, we learned about the classification and determination of geological age. Next lesson, let's learn the last point of this chapter: geological process